Tani ko sebun tani ko kan. So if you've joined, just type hello in the comment section as usual. If you've joined, just type hello in the comment section. If you've joined, just type hello in the comment section. I want to win. The bird. Hello, okay, welcome. If you've joined, just type hello in the comment section. If you've joined, just type hello in the comment section. So we are going to do FP, GP. This is arithmetic progression and geometric progression. So those that are joining us now, you can just drop a hello in the comment section. So this topic I think you did already at grade 12, so there is no need of us wasting much time since you did it already at grade 12. Michael, hello. Niza, hello. Okay. I believe a number of you have managed to join. I can see a number of you people are able to watch the live session. Right, without wasting our time, we can start. I believe you have where to write. As usual, this is a full session. So we expect to have all the concepts given. So under AP and GP, of course, it's just exactly as what you did at grade 12. I won't be wasting time on this topic because it's just the same way you did at grade 12. So what are the things that you need to understand on both AP and GP? So the things that you'll be required to understand from AP and GP are as follows. So the following are the things to know under AP and GP. One, the first term. The first term, don't forget to share with your friends. You can also subscribe to our channel because we are using this channel for the purpose of academics only. So try to subscribe to the channel. You can also like, to share, and your friends, they'll also be able to benefit too. So you can share with your friends for them to join as well. So the first term, which is denoted by M, all right, and then we'll also be required to know the second thing, which is called common difference, which is denoted by D. Number 3, we'll also be required to know what is known as common ratio. which is denoted by R. Then lastly, we need to know how to get an nth term from both AP and GP. That has to be fourth part, nth term. Oh, there are still things that we need to also be able to know. Number 5, it has to be sum of AP and GP. Then lastly, we need to also know what we call sum to infinity. Someone is asking in the comment section, is this mathematics? I don't know how I respond to that, but I think arithmetic progression and geometric progression belongs to mathematics, if I'm not mistaken. Yeah, that is the best response I can give. AP and GP belongs to mathematics. I believe network is just okay, such that everyone is able to see what is happening and what I'm writing. So these are the things that we are going to look at. I don't have time for me to start deriving some of the formulas, because this time around no one will ask you to derive. Such type of questions ended long way ago. So yeah, we'll just focus on the things that we need to know. So like I said, the first term is denoted by that, common difference is denoted by that, common ratio is denoted by that. Then we need to know how to get the nth term from both arithmetic progression as well as geometric progression. But before we come to that, we need to know what is the meaning of common difference and what is the meaning of the so-called common ratio. So when we say common difference, is the difference between the second term, which I will call T2, and the first term, which I'll call T1. So in getting the common difference, which is a D, you always say D is equal to term number 2 minus term number 1. Which means if you happen to be given a sequence of 1, 2, 3, 4, 5, 6, here for you to get the common difference, you subtract the second term is here, which is this one, also T2. The first term will be that one. So common difference here, D will be equal to, that is a 2 minus a 1, meaning that the common difference is 1. Same applies if you want to use the third term and the second term, you take this one to be term number 3. So you still subtract this by that, meaning that the common difference has to be term number 3 minus term number 2, which is equal to which is equal to 3 minus 2, that gives us 1. what we need to understand from the part of a common difference. You subtract the next term by the previous term. So the next term is this one, previous term is that. Next term is that one, previous is that one. That's how you find the common difference. So whenever we hear a thing of a common difference, we mean what is the repeated number, which when you try to subtract different terms, you are going to be getting. That's what we call a common difference. When you go to common ratio, a common ratio, it simply means the quotient you get after dividing the second term by the first term, the third term by the second term. So common ratio, which is R, is a quotient of the second term and the first term, third term and the second term, fourth. And people are asking questions that I don't know if maybe these questions are making sense. Operators, what do you mean by operators? That's okay. So if you've joined us now, you can just type hello in the comment section, given hi. Right, we proceed. This is Michael Sabia, hi. So common ratio R is equal to T2 divided by T1. So in this case, you notice that if you have things like 2 plus 4 plus 8 plus 16, definitely there it will give you the common ratio, which is going to be a number that will be the same when you divide this by that, when you divide that by that, divide this and that, you get a common ratio as a number which is just the same. That's how you understand what we call a common ratio. Let's try to also move on to the next, whereby we'll be able to know how to get the nth term between, the nth term from both AP and a GP. How do you get the nth term of AP and GP? No is saying hi. Welcome to this live cast. Welcome to this live cast. Let's try to understand what nth term means. An nth term for AP is always given by, so we say nth term, so Tn here is always given by the first term plus n minus 1 multiplied by the common difference. An nth term is always given by the first term plus n minus 1, where n is the number that you are trying to locate. If they're saying what is the seventh term, meaning that n has to be 7. If they say what is the second term, meaning that n has to be 2. So you notice that here, if you start with the first term, term number 1 as to why we are saying it is equal to an a, we take it as T1 is equal to, we say a plus, then on this part, what do we have? We have a 1. So 1 minus 1 is 0 multiplied by d. That's why we are saying term number 1 is always equal to an a. Term number 2, where n is equal to 2, we have a plus, then here we have a 2 minus 1 multiplied by d, meaning that term number 2 is the same as a plus the common difference, which is d. Term number 3, n in this case is equal to 3. If you check from here, so we have a plus, then there we have 3 minus 1 multiplied by d, which means term number 3 is the same as a plus 2 multiplied by the common difference, d. Okay, perfect. So these are the same things that you did at grade 12, like I said. So if you proceed going to fourth term, here the number changes, it will be 3D. Okay, let's try to, so in short, this is how you get an nth term of an arithmetic progression. For AP, an nth term is given by the formula which is there. What if you want to deal with the geometric progression? How can you get the nth term? An nth term for geometric progression is always given as, I'll say nth term, Tn is equal to A multiplied by the common ratio. You raise the common ratio to the power of n minus a 1. Which means if you are dealing with the first term, so this is for GP. If you are dealing with the first term under GP, how are you going to get the same first term? So meaning that for the first term under GP, n is equal to 1. So you say the first term here is going to be equal to A R to the power of 1 minus 1, which is the same as A R to the power 0. So remember, any number to the power of 0 is the same as 1. So meaning that you end up having this. The second term here, T2, is the same as A to the power of, AR. So on the part of n we have a 2 minus 1. So in short, second term is the same as AR. You proceed even to the third term and so on and so forth. Okay. So this is how you get the nth term for both GP and AP. They will also be asking you to calculate or to come up with what we call, or to write a given sequence in sigma notation. So for you to come up with a sigma notation, let me try to write that point here. To write a certain sequence in sigma, or sigma notation, which is denoted by this given symbol, comma, we start by testing if a sequence is either an AP or a GP. How is this done? For you to test if a given sequence is an AP or GP, how is this done? You can only test if a given sequence is AP or GP by calculating for arithmetic, the common difference and the common ratio. Yeah, so if you've just joined us now, you can type hello in the comment section. Don't forget to share with your friends for them to benefit as well. So how do you get to know if a given sequence is AP or a given sequence is a GP? You can only get to know if a given sequence is an AP or GP by calculating for common difference and common ratio. You start by calculating for common difference. If you find that the common difference is the same throughout, then that given sequence is an AP. Then after identifying to say this sequence is an AP, you have to go direct to this now, whereby you'll be able to know what is the first term and also the common difference. Then plug in everything, and your final answer must always have an n included. That's how you write a notation or a sigma notation. Let me try to write that down here. This is all done by finding the common difference and common ratio, then check which one suits. After finding the common difference and the common ratio, if it is a GP, you go direct to this part, and then you come and plug in your first term and the second term, then this part will remain like the way it is. Same applies if it is AP. You come here, you plug in what common difference you got and what is the first term, then n minus 1 will remain like the way it is. Okay, let's try to check from some questions that you can be given in a case whereby they want you to calculate for or to come up with a sigma notation out of a given sequence. Okay, I have some questions here from the tutorial sheet. Okay. Right. In short, before I come to this, let me try to also write the parts for sum of AP and GP. How do you get the sum of AP and GP? Who can try to give me a formula that you're supposed to use? What is the sum of AP and GP? What are the formulas that you're supposed to use for sum of AP and GP? The comment section is plain. You can try to help me with typing in the comment section. Type in the comment section, how do you get the sum of Sn is equal to what? Sn is equal to what? How do you get the sum of an AP? How do you get the sum of AP? Quickly try to type in the comment section. How do you get the sum of AP and GP? Hello guys, how do you get the sum of AP and GP? I need your help in the comment section there. How do you get the sum of AP and GP? Remember, whatever we're doing here, this is your full lesson. So when you understand it from this very part, it won't even give you problems to understand it when you start solving some questions. Given is saying sum for an APSN is equal to n over 2, open bracket, 2a plus n minus 1 d closed. Oh, thank you. This is so amazing. N over 2. Okay. I think we all agree to say this is the same formula that you are using even at grade 12. Nice. Lazarus is saying for an AP, Sn is equal to that, which is n over 2, open 2a plus n minus 1 d close for an AP. Thank you very much. That is very much correct. Let's go to sum of how do you get the sum of a GP? There is a document, the introductory part for this. You can check on the portal there when we are done, especially how do you prove for the formulas. How do you come up with this formula and the formula for AP, including the formula for sum to infinity? So someone is saying Sn, Niza is saying Sn is equal to A over 1 minus R for AP. Yeah, that formula is very, very important, but it applies somewhere else. It applies somewhere else, yeah. In short, that formula that Niza has brought in is a formula for sum to infinity. Sum to infinity is the one which is written like that. Let me even include it somewhere. Sum to infinity, okay, I'll write it later. So now it's saying for an AP, Sn n over 2. Try to finish your expression. Okay, Michael is saying n over 2, 2n plus n minus 1 d. That is almost correct. I need the sum the sum for a GP now. Sum for GP, how do you get the formula for sum GP? Sum for GP, which is geometric progression. Sum for GP, which is geometric progression. How do you get sum for a GP? Quickly, guys, give me the formula for sum to GP, for sum of a GP, geometric progression. How do you get sum of a GP? Sum for geometric progression, how do you write sum for geometric progression? Lazarus is saying Sn is equal to A, open bracket, 1 minus R, right? That is making sense. Especially when R is less than 1. When R is less than 1, this has to be the formula for AP. When R is above 1, it could be a number which is a 0 point something. It could be a number in a form of a fraction. It could be a number which is, in short, less than 1. This has to be the formula for geometric progression. When we come to the last part, where we are going to understand a different formula that Niza just wrote, that formula is a formula for sum to infinity. So sum to infinity, how do you write the formula for sum to infinity? Sum to infinity, which is denoted by this, is always equal to first term divided by 1 minus R. The first term divided by 1 minus R. So someone there is saying for GP, when R is greater than 1, it has to be A, open, R power of n,